Exponential functions. Yeah, we're getting into logarithms, but right now, y'all saw that logarithms deal with exponents, right? So the first thing we're going to do is graphs that have exponents with a variable. So this, I'm telling you, I really think that y'all did like one day in Algebra 1 with this. It's been a long time. But if you can graph, then you can do this. If you can graph any kind of equation, then you can handle this today. So one thing you can do if you don't have a calculator is make a little table of values. Let's pick some numbers for x. Like what numbers would y'all like to pick? How about like 0, 1, and 2? Okay. 2 to the 0 power, anything to the 0 power is 1. Anything to the 0 power is 1. Put it in your calculator, really. If you put 2 to the 0, it's going to give you 1. Okay? Then 2 to the 1 is what? Just 2. It means you write it once. 2 squared is what? 4. See how it's growing more and more each time? It's exponential growth. So if I plot those points, I'm up 1, over 1, up 2. See, it looks like a straight line, but it's not going to be. And then I'll go over 2 and up 1, 2, 3, 4. See? So it's going up faster and faster and faster and faster. And it's not going to be negative, okay? It's going to go that way. Now, if you don't want to graph that by hand, I told you I'd show you both ways. You take out your calculator, and you press y equals, clear it out, and you're going to type in 2 to the x. Does everybody see how I did that on my calculator? 2 to the x power. And then we would just press, can I keep going? Are we good? I would press zoom 6 just to make sure I'm in a standard viewing window. And there it is. Now, how would I get that from my calculator to my paper? Yeah, so instead of me figuring out the numbers, I can just go to my table. You press second graph, and there's all my numbers. Do I want to use all those little bitty decimals? No. So you can just scroll. I like these numbers, okay? And you can see that the y values are never negative. Like they don't ever get to a negative number on this problem. Okay, how was that?
I like just doing it without a calculator.
Either way is fine. That's why I'm going to show you both ways. The calculator does the same thing. See, look at my table and look at its table.
You can plot your points and see it when I have to go to your table. I remember
Yeah.
doing it. Easy.
Yeah, we've done this before. Let me do another one. All right, let's do y equals 2 times 3 to the x.
Can you do whatever you want to do? Like whatever numbers?
On what?
Can we always kind of do smaller numbers?
Well, like, I don't know what all they have. I'll have to look on your sheet. I don't even know what all kinds of numbers they have. On this one, I want you to see that what's being raised to the x power? Just the 3. So be careful with that, okay, when you go to graph it. It's not 6 to the x, right? It's 2 times 3 to the x. Okay, so if I go to y equals, I'm going to put 2 times, and I just like to use parentheses. You probably don't have to. 3 to the x. Okay? And when I graph it...
Wait, can you show me your thing?
Yes, I will. Sorry, I got to wait just a second. Okay. And now.
I'm going to pick 0, 1, and 2?
Yeah, I would usually pick 0, 1, and 2 because you can see that it kind of where it levels out at. Going to the left.
How would you do that one without your calculator?
I'll do it in a second.
Okay.
But if I graph, okay, there's my graph. And then let's look at our table of values. So again, I'm going to pick these numbers. 0, 2, 1, 6. See how much faster this one's going up? And then 2 and 18. If you don't want to do 2 and 18, you could try like -1 and then 0.6 repeated. That's really not that bad.
Could you do... Never mind.
So watch, I'm going to do 0, 2.
Quick question, how did you get to that table?
Just press second graph. See the little yellow? You might not can see that, but right above graph, it says table. Okay? So I went 0, 2. I'm going to go over 1 and up 6. But I don't want to go up to 18. So if I wanted another point, I could just go to the left -1 and know like it's somewhere in there, right? And then I know it's going up faster and faster, and it's going to level off. Okay, if you didn't have your calculator, but I think the calculator may be a little easier because this one is the most basic. That one was easy to not use a calculator. But you would just plug in some values for x. Let me zoom out and I'll write. I guess I can write the little table right here though. So let's pick 0, 1, and 2. If x was 0, 3 to the 0 is what number? 1. And what's 2 times 1?
2.
Okay. Because we're multiplying by 2. 3 to the 1 is 3, but then multiply it by 2. 6. Okay? Then 3 squared is 9, but then we have to multiply that by 2. And we would get 18. Okay? No, it's not that bad. It's still the same idea. Let's see what we have next. They want us to just look at some problems and decide if it's exponential growth, exponential decay, and maybe where the asymptote is. We talked about asymptotes, right?
I don't know.
Where you can't, an asymptote means that you can't get to that line. You can get closer and closer and closer to something, but you can never get to it. I've told y'all about dividing by 2, right? If you start, or if I was to go halfway to that door every time, if I was to start here, and I was just going to say mathematically, I know not physically, but mathematically if I said, I'm going to go halfway to that door constantly, I would never get through that door. I would never, mathematically I could never get through that door. It's the same idea. If you keep taking half of something, you'll never get to 0, ever. You could try it on your calculator. Like if you started with the number 40, okay, divide it by 2. Divide it by 2, divide it by 2. If you keep dividing by 2 forever and ever and ever and ever, you're going to get close to 0, but you will never get to 0. That's an asymptote. It means you get closer and closer and closer to it, but it doesn't ever reach it. We'll see those a lot in advanced math. So exponential growth, that's when it's going up. Exponential decay, that's when it's going down. Okay, is everybody good with that? Then let's see, we'll need this. Okay, I won't move it yet. I'm just going to show this box next. I'll give you a second. Let me pause it. Now, I'm going to raise this up. This is what we're looking at right here. It's a lot of words. So let me just say, without all these words, what they're trying to tell you. The number b that's raised to that exponent, if it's between 0 and 1, like 0.5 or 0.8 or 3/4, like those numbers are smaller than 1, right? A positive number, but it's smaller than 1, then it's going to be exponential decay. That's what it's saying right here. If the b is between 0 and 1, it's exponential decay. But if it's a number that's bigger than 1, it's exponential growth. Sometimes I like to say, oh, if it's a decimal or a fraction, it's exponential decay. But that's not the case, because 3/2 is a fraction, but it's bigger than 1. Right? So you're looking at numbers between 0 and 1, or is it bigger than 1? Is it decay, or is it growth? So if we look at these, like, can y'all see A? Well, here you'll see the answers, but it's fine. Like, look at problem A. This number right here is less than 1, so what is it?
Decay.
It's decay. Okay, that's it. That's as easy as it's gonna get. Yeah, this number right here is bigger than 1, so what is it? It's growth. Okay. Let's see.
What number is bigger than 1?
The number that's under the exponent, that's raised to that power x. Like this number right here, 0.95, that's between 0 and 1, so it's decay.
What if it's a negative number?
I don't know that it will have. I think somebody asked me that last time, and I never saw a negative number, ever. I don't think for these types of problems you're going to have a negative number under there. Let me see what they do about C. This one, well, if you're putting into a savings account and it pays 5% interest annually, don't think about numbers here. Just think about what's going on in the situation. Is it going to make money, or are you going to lose money? You're going to make money, so we call that growth. Okay, just think of what it's telling you in that problem. Let's see. If you look at this one, 4, it's bigger than 1, so it's growth. That's smaller than 1, so it's decay. This one, again, the same thing. They're going to pay you 6% interest annually. You're making money, so it's what? It's growth. Okay. Then they wanted us, let's see, I think they want to tell us to tell the Y-intercept. Okay, so, and that's going to be on your problem too. For the Y-intercept, this goes all the way back to algebra. So y'all can say growth or decay, growth or decay, growth or decay. Now for the Y-intercept part, because you're going to have it on your worksheet, all that means is if x is 0, what is y equal to? Okay, basically anything to the 0 power goes away to what? 1. So if this goes away, what number am I left with? 12. That's my Y-intercept. Okay, if this goes away to 1, what am I left with? 0.25. That's my Y-intercept. Do we understand that? On this one, let's see. The Y-intercept, oh, it's just your starting value. How much did we start with? $1,000. Okay, remember Y-intercept is kind of like, it's your starting value. Where do you start from? All right, on this one, what's my Y-intercept? That would go away to 1, so the Y-intercept is 3. Okay, this one, the 0.75 to the 0 goes away to 1, so what's my Y-intercept? 11. And on this one, what's my starting value? What's my Y-intercept? 2,000. How are these? Are we ready to do our first set of graphing in these? Okay, because I think we're like, I don't know, not quite halfway done, but almost halfway done. Why is that not? There it goes. Now, this is our next equation, all right? This is whenever we're dealing with maybe money and we're trying to figure out how fast your money is going to go in a savings account. So if you were to go to, what is that, Barksdale Bank?
Yeah, Barksdale Federal Credit Union.
Yeah, so thank you, Dad. So they have like a Christmas club. Have y'all ever been like to put money in the Christmas club? So I think they get like 3% interest. Something about you can put up to $5,000 in there, but then you'll make 3% throughout the year, and you can kind of figure out, hey, how much will I have at the end of the year? So this is when you use this equation. You can use it for growth or decay. So if it's growth, notice that this is your initial amount, the A, that's your starting value. Remember we did number, what one was it like that? In the book, we did some like that, right? Where they say, okay, you start with $1,000 and then it's growing at this percent. So guess what A is? A is $1,000. That's your starting value. The R is the rate that you're growing. If it's 30%, how do I write that as a decimal?
Wait, which A is $1,000? There's 10.
This one right here.
The blue A.
The little blue A, that's your initial value. That's what it says, your initial amount. So you would put, okay, $1,000 right there. If it was growing at a rate of 30%, whatever we're talking about, that would be 0.3, right? So I would have 1 plus 0.3. And then T, notice they use the letter T and not X. That's because they're dealing with time, okay? And that's the formula you're going to need to know. If it was decay, would I put 1 plus R? No, I would put what? 1 minus R, because you would treat that rate as if it was negative because it's decaying. It's going down. So that R would be negative. Let's look at this word problem. All right, I'll read it and then I'll make the equation from it. It says that you invest $1,000 at the end of 6th grade. The account pays 5% annual interest. How much money will the account have after 6 years? What's your initial amount? 1,000. What's your R? 5%, which is what number? 0.05. And what's our T, our time? 6 years. 6. Okay, so I'm going to plug all that into my equation, and my calculator, it can handle all that for me. Let me come over here. So if I had, and I'll use the letters that they use, AT, that's the amount after time. So our initial amount was 1,000 times 1 plus 0.05. The whole reason for adding 1 is because when it's growth, it has to be bigger than what number? 1. That's why you had to add 1, okay? Because it has to show that it's growth. Oops,
So
sorry.
what if it's one?
And then to the 6. So yeah, that is 1.05.
Yeah, so then you wouldn't have.
So you could type all that into your calculator and it can give you the answer. Okay, or you can take it step by step, but I'll show you on my calculator.
All that in your calculator.
So I would type in, 1,000 times. Then if they have parentheses, what do I need to put?
Parentheses.
1, I'm just going to go ahead and put 0.05, right? Isn't that 1 plus 0.05?
And it's not fast.
To the 6th power.
I got a big number.
Okay, well, after 6 years, if you started with $1,000, huh?
Like a variable. You start. Oh, I forgot.
6 was our time, 6
So
years.
you don't have to put the 2.
No, you put 6. You have to put the 6 because we're trying to figure this out.
Oh.
You have to plug in the 6 for our time. So they started with $1,000. After 6 years, how much money do they have?
It looks like 1,000.
Not very much.
Not very much. No, $1,340 and 10 cents. $340. Yeah,
Damn.
but it made something. Okay. That's why a lot of people choose to do like money markets and things that have a bigger return than a savings.
I'm ready for Christmas.
Do we understand that?
I am too.
Yeah.
Let's see our other problem. So listen, on number 14, we'll come back to number 13 in a second. Y'all look at
Wait, is
14.
that what we did on 13?
It is.
What we're gonna do on all of them?
It is what you do on all of them. But now you can't do C and D on 13 yet. You can do A and B on 13.
So X it out.
No, I'll go over that with you in a minute. I just haven't taught that. But look, 14, 15, and 16, you can do. On 15 and 16, it says it decreases and it depreciates. What does that mean? It goes down. So it's going to be a minus sign or a negative number. So make sure you do that. Now, y'all try these. I'll put this formula back up here.
We want to do 14.
So 14, 15, and 16, and you can start number 13.
Okay, so like number 14.
Thank you. All right, number 13, and then I'm going to show y'all how to do some on the back. Number 13, y'all should have been able to do A and B. Now, for part C and D, I want to write down our equation. I'm going to use y equals because that's what my calculator looks like. What's my starting value on this problem? 1,500. Okay, and then am I adding or subtracting?
Add it.
I'm adding 1 plus 0.06, right? Because it was a single digit number. And then I'm putting, like on this one you put to the 5 years. On this one you put to the 20. Okay, but on this one it's saying how many years. So when you don't know, what variable do we use? X. So what they want us to do is find out what's X gonna be if our Y is this. Now you could go through and solve this mathematically. We don't know how to do that yet because we haven't done logarithms and stuff really. We'll solve equations like that later, but all that can be done with a calculator. I need to borrow one of those real quick. And I'll let you try part B. Thank you. Thank you. Okay. So I'm going to go to my Y equals. Does everybody understand how I got my equation?
Yes.
Okay, so I'm going to go to Y equals, and I'm going to just type that in. 1,500, and that's a really big number,
Yeah.
times
And,
1.06, or you could have put 1 plus 0.06 if you wanted to. That's the same thing,
Yeah.
to the X.
sorry.
What?
Nothing. I was talking to myself.
Oh, now if I press graph,
This is arrow. No, it didn't say
Let's see.
It said arrow.
Mine just don't go nowhere.
so we can't really see it because it's really high up, right? Because 1,500, it's all the way up at 1,500. That's my Y-intercept. Remember learning that?
Yeah.
So it's way up there at 1,500. Now, I don't even really need that. I want us to just go to our table. So we press second graph. What do they want our Y value to equal?
2,500.
So if I just go and scroll down to 2,500, do I see it? Oh, What's x going to be? 9. So it is going to take it 9 years, somewhere between 8 and 9 years, to get to
So
2,500.
your answer would just be x equals 9.
So yeah, it's going to be
I
9
said
9 years. Let me see what they put, if they put 8 or 9.
That is for C, correct?
Yeah, they put about 9 years for C. Now, I want y'all to try D. It's the same exact equation, correct?
Yes.
So you already have that in your calculator. What are you going to
Y
scroll
equals
down to?
2,000
No.
plus-
Y
Yeah.
equals 17.
So you have the same equation, but you're going to scroll down to 4,000. Does that make sense, y'all?
Yeah.
That's the easiest
What
way
is it,
to...
17?
Because I just stayed
You
on
gotta
here
scroll
and I
down until you
scrolled
see
down
4,000.
until I saw 4,000.
So yeah, it was already ready for you to do that one. Okay, then the back. We still have 15 minutes. The back is not bad at all.
Well,
These I don't think are in your book.
Do we have a book?
Yeah, if you want one, you can always check one out.
Okay.
So I'm going to show you how to do 17 and 18, and you're going to do the rest through 24. Go ahead and do 17 and 18. No, very easy. Because I'm giving you points for all this, right? It's easy points. We need to bring up some grades. So if I'm looking at my rate of 45%, what was in my parentheses? 1 plus 0.45. So it's 1.45. That's just what's in my parentheses.
In this case,
How'd you just pull that out of your butt?
Okay, remember, if it's a positive, if it's growth, it's 1 plus that number.
Okay.
So, and I have to write that percentage as a decimal. Yes.
So number 18 would be
So it would be 1 minus.
It's going to be 1
0.10.
minus 0.10,
so 0.90.
0.90.
So that's decay.
That's decay. And remember,
You have to write
that's
it
why I
right.
told you it's never a negative number in there, because you're going to take you're going to add 1, or you're going to do 1 plus that number, or 1 minus.
0.90. I got 0.99.
So that'd be point.
1 minus 0.10.
Oh, I'm done.
Would that, would
That'd be
119 be 0.60?
This is 1 minus 0.40, which is 0.60. And that's your decay factor.
20 be 3.
Do what?
Yeah, 120 be.
3.
So you would get, move it 2 places.
Whoa. Miss
Uh-huh.
Casey.
Yeah, that it is. Now, and look, your negatives, notice your negatives are less than 1. What are all your positives? Greater than 1.
So what the negatives just be decay?
The negatives are decay. That's why we're doing 1 minus
is
that.
21 1.28?
Hold on.
I
Let me-
know right now. I was just about